will see about the types of transmission media. Types of transmission media. What are the types to transmit the data from the source to destination? Here, the definition: the data is represented by the computers and other telecommunication device using signals, right? And the signals are transmitted in the form of electromagnetic energy from one device to another device. So the signal are transmitted like that. So the electromagnetic signal travel through the vacuum or air or other transmission medium to move from one point to another point. That means sender to receiver. Okay. So the electromagnetic energy, it includes the electrical and the magnetic fields like power, voice, or radio waves, ultra waves, gamma, or whatever it is. So these are the electromagnetic energy. Then the transmission medium is a means through which we send our data from one place to another. From one place to another. The first layer here, the first layer of the communication network is a OSI is a layer of a physical layer. The physical layer only is going to transmit or convert the bits into signal and transmit to the media, right? And yeah, this is a types of transmission media. This is a types of transmission media. So what are the types here? So the types is divided into two types. First one, guided media and unguided media. That means wired media and wireless media, nothing else. The transmission media is like first one, the wired media. Then second one, there is a unguided. And the guided media is divided into three types. Guided media means that is a wireless media, that is wired, so wired media. So the wired media is divided into three types. First one is a twisted pair cable and a coaxial cable and the optical fiber cable. Optical fiber cable, right? So this is a range, electromagnetic spectrum for the transmission media. Here the power, voice. So the radio communication between the ranges. So 3 kilohertz to 300 gigahertz. So that is a radio communication microwave ranges. It may be with the infrared or ultraviolet. So these are the ranges used in the electromagnetic spectrum. And this is a diagram to explain the low frequency to the high frequency. This is a low frequency diagram. That is a 10 kilohertz. So maximum it's used in the tower or like that. If the high frequency means it's a X-ray or that is MRI scan. So like that. So the gamma rays, this is a high frequency. So this is a range from low frequency to high frequency. Why I am talking like this? Because the signal can transfer the data. So we should know what is the frequency of the signal. So the other application of this level here, this is a diagram for the application of this level of frequency. Okay, so here the application level of the frequency. So the first one, DC to 300 gigahertz. So this is a gamma ray. So where we it's used the medical X-rays and here the sub-base AC power monitor. So for the mobile phones, we are using only the radio frequency spectrum around the 30 kilohertz to the other ranges. So this is a range, right? So the electromagnetic spectrum is calculated by the wave or signals, right? And this is a unit of the other kind of the method, the unit. That means the first one, the kilo and the megahertz and gigahertz, terahertz, beta and hexa, whatever it is. So these are the ranges of the kilohertz to the beta, extra, zeta. So these are the ranges. And the next one here, the guided transmission media. Already I told, guided transmission media means that is a wired media. So wired media, the transmission capacity depends upon the distance and whether the medium is a point to point or the multi-point. Point to point or the multi-point. So example, the twisted pair wires. Twisted pair wires And the coaxial cable, here the fiber optical method, here the fiber optical method. First one we will see the twisted pair cable. Here twisted pair cable, the first one, the consists of two insulated copper wires arranged in the regular or spiral pattern. That is a small kind of the twisted pair cable, right? To minimize the electromagnetic interference between the adjacent pair. That is the first one, the twisted pair cable method. Often used at customer, that is facilities, and also the distance carry over the voice as well as the data communication. And also this is a very, very low frequency transmission medium, which is twisted pair wires. Yeah, this is a diagram for the twisted pair wires cables. There is a range from 100 kilohertz to 5 megahertz. 100 hertz to 5 megahertz twisted pair cable. Just the two wire is paired with the, so it's a solid copper conductor and the output of PVC wire, like telephone wire. That is an example of twisted pair cable. And it is also divided into two types. First one, that is a STP and UDP. STP means that is a shielded twisted pair. That is shielded twisted pair. UDP means that is an unshielded twisted pair. So the shielded twisted pair means the pair is wrapped with the metallic foil for other kind of that is a shielded. Actually, this is a more productive. Unshielded means it's just a plastic wrap and it's a pair of enclosed with the some other covering. Wait, I will show the diagram. Yeah, this is a diagram for twisted pair. Here the shield and unshield. Unshield means that is the only the plastic cover between the two cables. But here the STP, the metal shield is covered for the more protective for the wires, and it's looking good. The quality level, the STP is best, right? Because there is a no here the metal shield is covered with the two cables, right? And the unshielded twisted pair here they used for only the telephonic applications. And also advantage is very least and expensive and easy to install, high speed capacity. Disadvantage is here the lower capacity and the performance in comparison to the STP, very low capacity, lower capacity. And shielded twisted pair, here this type of cable consists of special jacket. That is nothing but that is a metal coverage for the other kind of the paired cable. So used fast data rate. We can send the fast data rate like a Ethernet and the voice data channel where it is used. So comparatively, it's faster and also it eliminates the crosstalk. Disadvantage is more expensive. First one, it is a more expensive and some difficult to install and the manufacture. So this is a shield twisted pair disadvantage. Okay, this is a diagram. Okay, then unshielded twisted pair cable is another kind of, there is a type of cable. There is a plastic cover with non-covered with any metal data, the twisted pair cable with the 5 pairs, and also it is not secure because if any one is breakable means the entire communication or the data transfer will be lost. So this is a untwisted pair cable, different type, there are 5 pairs. And also it is used with 4 conductor or 6 or 8 based on the situation. Shielded twisted pair cable here used in the plastic cover and the metal shield and the insulation, then the copper. Insulation, then the copper. So, so this is the insulation of the copper is more protective with the metal shield. And yeah, this is another one diagram for the twisted pair cable. It is connected with the one device to another device. So we can use this for make a connectivity for topologies. Topologies, we can use the twisted pair cables to connect or make the mesh topology and star topology, whatever it is. So the connectivity can done by the twisted pair cable. Okay, fine. Then here, um, the ratings of twisted pair cable. Here the Cat3 cable, Cat5 cable. Cat3 means there is a performance wise the data rate is low. Only 16 Mbps are achievable. If I'm using the Cat5 cable, I can send the data rate of the 100 Mbps is possible, right? And also it's some compared with the Cat3, it is some expensive only. Then STP means it's more expensive compared with the other UTP, right? And also it's difficult to install the STP method. And the advantages of this twisted pair here, the inexpensive and readily available and flexible and lightweight, easy to work with and install. That is a twisted pair cable advantages. Disadvantages is here the attenuation problem for analog and digital for the repeaters for 5 to 6 kilometers and 2 to 3 kilometers, because you have to make some another one adapter to attach to maintain the frequency. So it is a main disadvantage of the twisted pair cable, and also it is a very low bandwidth. It is a very low bandwidth. Next, there is a coaxial cable. So what happened in the coaxial cable? So it has an outer plastic covering the containing the two parallel conductors. Two parallel conductor, each having a separate insulated protection cover. So compared with the twisted pair cable, it is more secure and it's more quality. The quality level will be very high in the coaxial cable, right? So they carry a higher frequency range compared to the twisted. Yeah, yes, right. So used for the cable television, you know that that is a cable TV wire, right? That is called the coaxial cable. And the LAN and telephony, moreover, it is used for LAN and the telephony wire also. And here the structure of the coaxial cable is nothing but the both conductors share the common center axis. So axial means that is a coaxial. And the next one, here it's divided into baseband mode and broadband mode. It's worked with the baseband mode and the broadband mode. So the dedicated cable bandwidth and it's a separate range. We can split the range using this coaxial cable. And yeah, this is a diagram of coaxial cable. So the range is 100 kilohertz to 500 megahertz. That is a range of the coaxial cable. This is a structure. First one, the plastic cover and the outer conductor, the shield outer conductor and the inner conductor with the copper. Right? So 1, 2, 3, 4. So there is a 4 insulation method to protect the data. Why it is so secure? Because if it is connected with the outer conductor and the inner conductor, the data will be transferred without any interrupt. So only the coaxial, because we need the excellent quality of cable to transmit the digital or the video level, the video converter. Because cable TV means you can see the television without any interrupt, right? So so the wire quality should be very high. So only we are choosing the coaxial cable to transmit the videos. And BNC connectors, yes, we need to some BNC connector to access the coaxial cable. There is a 3 type. First of all, it is a 3 type. The normal BNC connector used for the cable TV set. It is a normal this is a diagram. The normal BNC connector. You can see this BNC connector. Small box is connected in the cable wire. You can see. Then the T conductor means that is another Ethernet connection or ND device. We can use the T connector. And the terminator here used for the cable to prevent the reflection. The wired ground, the ground wire to be connected for the reflection. So this is a type of BNC connectors. So coax application and the advantages. So the application is long distance telephone transmission and can carry the 10,000 voice calls simultaneously. So now you can imagine how it is a very quality and the valuable, right? and also used for the cable TV and the LAN connection. The main advantage of this coaxial cable here, the higher bandwidth first one, and 400 to 600 megahertz, that is a range, up to 10,800 voice conversation at a time, right? And also easy to wire and easy to expand, and it is tapped easily. So compared with the twisted pair cable, coaxial cable is best to transfer the data and the range. Then the disadvantage is higher attenuation rate makes it expensive, and for the long distance it's some expensive, right? And the cost of installation and the maintenance is also high. That is a disadvantage of coaxial cable. Next, we will touch the fiber optical cable. The fiber optical cable is ultra speed data transfer method for the latest level of the cable. Here, the fiber optical cable. Around you can transfer the data around 1 GB. That is 1 gigabytes gigahertz. You can transmit the data. Relatively, the new transmission medium used by the telephony companies plays long distance trunk lines and the local data communication. Then ILD, that is a injection laser diode, and LED, that is a light emitting diode. They are using only the fiber optical cable, right? And also the core surrounded by the less dense of glass or plastic covering called the cladding. So the cladding is covered with the plastic or glass. It's a very expensive, first of all. And the next thing, yeah, this is a diagram for the fiber optical cable conductor. Here, this is outer jack, and some buffer is here to transmit the data easily. And the fiber, this is a fiber. This is a fiber core or cladding. So the data will be, or the signal will be transferred very fast through the fiber construction cable. And it is also divided into some type. There is a multi-mode and a single mode. Single mode only we are using here. The multi-mode using with the step index and the graded index. You will see one by one. The fiber optical types here, the multi-mode, step index, and fiber. So the reflective walls here, the corresponding reflective walls, there is a main thing. Reflective walls of fiber move to light pulse with the receiver. And the multi-mode, the graded index fiber means it acts as the refract. First, I will explain what is a reflection, what is a reflect. Then single mode fiber means here the guided down as center for an extremely narrow core. This is a different types of the fiber. See, this is a reflection. This is a refraction. The reflection means nothing but some certain angle. Whatever this angle, the around 90 or 180 angle, the reflection will be transmit the data, but not the full wavelength, right? So the direction of wavefront at the interface between the two different media. So the wavefront returns into the medium from which is originated. So this is a reflection. Reflection is normal reflection. When it is reflect, when the corresponding the structure of the cable will be bent or any direction, it will be the reflection will happen. Refraction means here some one medium to another medium result to the radio waves. It's based on some angles and beam and the front more dense. So don't think this is so confusing. You just imagine the corresponding cable will be send the data, either it's a reflection or refraction is a process. Then the fiber opticals here, the bending of the light ray. There is a two method here using the angle of incidence and the critical angle. The angle of incidence means the angle the rays makes with the line, then the perpendicular to the interface between the two substances, right? So the angle will be decided to send the data with the same frequency. Those frequency level should be equal in the either of angle of instance or the critical angle. The 90 degree of angle is a critical angle. It should be sent to the same kind of quality of data transfer. That is a fiber optics, the bending of light rays. And the next one, the same angle. What is the critical angle? It should be in the 90° of the angle. So you just imagine, first you understand, compared with coaxial cable, compared with the Cat3 cable, Cat5 cable, and the twisted pair cable, the fiber optical cable performance will be very high, right? It should be very high because the range, the data transmission, everything is very high compared with previous one. So this is a signal mode. This a source should be like this, means the destination is like this in a single mode. If it is a multi-mode, means this is a multi-mode step. So step index, it should be the signal will be very fast. It will be, the flow of signal will be like this, the destination. Source will be like this. This is a source, but the destination will be changed compared with the single mode and the multi-mode step index. Then multi-index means, graded index means it is also very fast. The frequency range will be very fast like this. Then the fiber optical signals, the fiber optic signal, optic multi-mode step index method, and the fiber optical multi-mode graded index, then the single mode. So this is a way of the optical signal transmit the data through the fiber optical cable. Okay, what are the advantages of the fiber optical cable? Here the greater capacity, the bandwidth up to 2 Gbps, up to 2 Gbps, not only one, it is a 2 Gbps is a bandwidth of fiber cable, and a smaller size lighting weight. So it's a very smaller size compared with the coaxial cable and twisted pair cable, and the lower attenuation, and also the environmental interface, because it is highly secure due to the tap difficulty, lack of the signal radiation, right? So this is a high secure. So these are the main advantages using the fiber optical cable. Fiber optical cable. So nowadays Jio, Airtel, ACT, so these are provided for the fiber optical cable internet connection. Around monthly 800 or 700 with 50 Mbps speed minimum. It is provided with 300 Mbps speed, right? Around 1900, I think. I don't know that, but the fiber optical cable will be data transfer and the excellent performance to using the Ethernet connection, right? And then fiber optic disadvantages of application, nothing else. It's very expensive, that's all. It's very expensive over the short distance and require highly skilled installer, and adding the additional needs to is difficult. Application level of the fiber optical cable, so many applications, not only the Ethernet connection, we can use the telecommunication, they can use the local area network, the LAN and the cable TV, and medical education. Maximum it's not used for the cable TV, but the medical education and the telecommunication local area network, probably it is used for the fiber optical cables. Fiber optical cables. And okay, so in this unguided media, here this is a wireless media. So unguided media transport the electromagnetic waves without using any physical conductor. That means any wired devices. And these types of communication are often referred to as the wireless communication. So what are the types? What are the types of wireless? First one is the radio waves, and the second one is the microwaves and the infrared. So in this radio wave, it's an electromagnetic spectrum for the wireless communication. So this is a range for the radio wave, that is 3 kilohertz to 300 gigahertz, and this is the range of infrared. And the light wave is up to 900 T, that is a terahertz. Here this is a 3 propagation types. That is a waves transmit either it's a earth or sky or the ground level, the ground wave or the space wave. Yeah, this is a ground wave, ground propagation, and the sky propagation, and the line of sight propagation. So there is a various range of waves will be propagation method in the wireless media, right? So the ground propagation means it's an antenna transmit the signal around the to pass the signal, and the here the sky propagation means the antenna to another one signal processing through the satellite, and its complete satellite communication is a line of sight propagation, right? And the first one is the ground propagation. So in ground propagation, the radio waves travels through the lowest portion of the atmosphere. That means the ground and the earth, right? So there is a ground propagation. So the very low frequency signal that is in all direction, it emits the all directions and transmit the antenna, then follow the other kind of transmission method. And the wave that propagates close to the surface of earth, so only it is a very low frequency, like mobile antenna tower, and any signal tower is a ground propagation method through the wireless communication, right? Then next is sky propagation means that is a higher frequency radio waves then radiate then upward into the that is a layer of atmosphere. So the reflected back to earth, that is a satellite communication is a sky propagation method. Okay. Here there is a line of space propagation, that is a atmosphere is extending 30 miles to 300 miles. So the satellite communication is a ionosphere wave transmissions, and also the electrons speed up and resulting is a weak conduction method. So yeah, line of sight propagation means the same one. There is a very high frequency signal transmitted in the straight wave. Here the straight line directly from antenna to antenna. Don't imagine the mobile antenna. It is a satellite. To one satellite antenna to another satellite antenna, that is a line of sight propagation method, and the antennas must be the directional, right? It's a line of sight propagation method. And this is a band. So what are the band and the range propagation and the application? So you just recall this the range of frequency and where it is used and what are the application is used for this. So the band very low frequency, LF means very another low frequency, then the middle frequency, high frequency. So these are the bands, right? So here the first two one is a ground propagation, and the second two is a MF and the high F is a sky propagation for using, for example, of the FM radio, and here the sky and the line of sight. That is also the FM radio. Then UHF TV, cellular phones. That is a line of sight. These are the line of sight. And the ultra high frequency, super high frequency, extremely high frequency, the EHF. So these are the bandwidth, and these are the range, and these are the propagation. Simultaneously, these are the applications. Okay. And next is a wireless unguided media. The two types. There is a two types of transmission, and the is achieved means the antenna, the directional or the omnidirectional. So here the directional means the transmitting antenna puts out a focus on beam, and the transmit the receiver must be that is aligned. That is and transmit the microwave. So this is a directional level. Omnidirectional level means here the signal spread out in the all directions can be received by many antennas. That is a omnidirectional, and transmits the radio wave. So that is a microwave. This is a radio wave. So there is a two types, right? And here, yeah, this is a radio wave and a microwave. Then infrared. So this is a single directional. Is a omnidirectional. Is a infrared directional. So the radio waves, the range of frequency is 3 kilohertz to 1 gigahertz, normally called the radio waves. And also the radio waves most part of the omnidirectional, and the radio waves particularly those low and the medium frequencies, right? And when the antenna transmits the radio media, they are propagated in all directional. So right, the FM radio is an example of radio wave. So the frequency will be 3 kilohertz to 1 gigahertz. And sending antenna send the waves that can be received by any receiving antenna, right? And yeah, this is an example diagram for the omnidirectional antenna and the application of FM radio, then cordless phone, and one sender but many receivers. So these are the omnidirectional antenna of the radio wave. Yeah. And the property of you have to install the antennas and the receivers and etc. These are the cost expensive, and this the radio waves transmitted by one antenna or susceptible bar interface by the another antenna, because the frequency band is should be same, right? These are the some of the disadvantage. And the radio wave propagation method means here just under 1 gigahertz compared to the microwave and band. When this band is divided into sub-bands, the band are also narrow and leading a low data rate for digital communication. This is a radio wave propagation methods, that is ranges, right? So the almost the entire band are regulated by the authorities. Then again, the radio waves application means here we can use the radio such as radio, television, then paging system, then through walls. So these are the use of the omnidirectional antennas. We are using the radio waves application in the real time. Microwaves means it is also 1 to 300 gigahertz. Is a 300 gigahertz. 1 to 300 gigahertz is a microwave, that is a electromagnetic waves having the frequency. And also it's a unidirectional. There is not a single directional, it's a unidirectional. So when the antenna transmit the microwaves, they can be narrowly focused, right? So here this means the sending and receiving antenna need to be aligned. For example, DTH. That is the exact frequency should be aligned with the waves. And the microwaves propagation is a line of sight. Here, this is a line of sight. Since the towers with the mounted antennas and need to be direct sight of each other. So the towers are the part of need to very tall, and very high frequency microwaves cannot be then penetrated for walls. So these are the utmost range and the possible of microwaves propagation. Yeah, this is a dish antenna, then horn antenna. There is a two types, right? So dish antenna will be in focus, and the horn antenna will be there is a wave guide of eliminate the waves. So this is a focus wave. This is a focus wave. It should be in high. So the dish antenna is an example of the microwave. Here the unidirectional antenna means here the microwaves needs to unidirectional antenna send out the signals one directional. So the two types of antennas are used in the microwaves communication. One is the parabolic dish and the horn. So the dish antenna and the horn antenna. So the parabolic dish antenna means here the geometric of parabolic, that is a kind of focus method. So every line parallel lines are reflection of the curve of the angles. So should be the curve of the angles. So that is called the focus method. And also catching the wide range of waves and the direction down to the common point. So this is the main thing for the dish antenna, right? Here the horn antenna, already I show the image, like the horn antenna to transmit the data and the broadcast the horn aimed to the corresponding dish. This is a transmission, that is a receiver, sender and the receiver, like type of sender and the receiver. And it is a manner the very similar to the dish and deflected down into the stream. So this is application of the microwaves. So there is a unicast communication such as cellular phones and satellite networks and wireless LAN. Very simple example, that is a DTH, right? So the DTH is to receive the signals and pass to the video conversion to the television. So that is if you want to get normal SD channel and HD channel, ultra HD channel, 4K channel. That's also, so there is a 4 types of channel in the that is a category in the DTH, right? So the SD means the antenna should be in some very low frequency, received very low frequency. HD means there is a better frequency. Ultra HD means there is a best frequency. Extreme high frequency will be received for 4K. 4K projection of receiving the signal. So the antenna should be adjusted based on that. Everything is available in the air, but your antenna should be aligned for the particular frequency. Then only you can receive the 4K, Ultra HD, HDR, SD, whatever it is. If you are installed Tata Sky DTH, means that should be aligned for the particular frequency. Then only you can receive. Like the FM is also like that. Radio frequency is also like that. It should be aligned. The corresponding receiver antenna should be aligned for the to receive the corresponding frequency, right? So this is a microwave application to receive the entire data here. Infrared means already you know about it. You know, within the room, you can use the short range communication system. There is a infrared. So if I'm operate one infrared signal from one room, it will not reflect in the another room, because the single room, the very close distance, we can operate the system. Very example is the remote TV remote, DTH remote. So that is called the infrared waves, right? So the range is 300 gigahertz to 400 the terahertz. And we cannot use the infrared outside the building. Yes, already I told, because the sun rays contain the infrared waves contain interfere. That is interfere. Interfere means it distract. The infrared will distract when you are the sun rays is entered into the infrared ranges. Then here the infrared, the short range communication in the closed area. It is also the line of sight propagation method. And the difference of fiber and satellite. So what is the difference of fiber and satellite? Here the bandwidth and the immunity to the interface, then security, multi-point capability, flexibility, and the connectivity to the customer side. So this is a Cat6 and the optical fiber, then the satellite. There is a two kind of method here used for there is a limit of range 1 terahertz to 1 gigahertz. That is currently used for the optical fiber. Here this is a 36 to 72 megahertz. That is a bandwidth range. And this is electromagnetic. Here subject to various source, including the microwaves or radio wave, depends upon the circumstance and difficult to tap without detection. It is a signal must be encrypted for the security purpose. And this is a point-to-point medium. This is a multi-point medium, because satellite can transmit the data to the multiple towers, right? And the flexibility is it's reconfigured to meet the changes. It is easy to reconfigure. So these are the Cat6 and the for optical fiber and the satellite. Okay, for that is a wired and wireless. Very simple. Wired and wireless, Cat6 of bandwidth and security, multi-point capability, flexibility, like